Okay, ladies and gentlemen, hopefully you all are doing really well. It is getting down to the last little bit before the AP exams. Next week I'm going to be doing more AP Gov review since that's the first exam, but I want to cover the last unit. We are down to the last unit in AP Micro, which is good because that test is obviously coming up. I wish I could tell you that the last unit on AP Micro was super exciting or anything like that. It's not. But what we're going to try and do is knock out just in a couple of videos over the next week or so. We'll try to knock those out and then have any questions and all that. We'll kind of go through those and give you an assignment or two on this as well. So the topic for this last unit, which there's a fair amount of graphs this we'll get to. Last unit is called derived demand. It's also sometimes called factor costs. Basically, what are the demand, what are the different effects of the factors of production. Now, if we go back to the beginning of the semester, the factors of production were things like land, labor, physical capital, all of that. Typically, the AP only focuses on two things. Labor is the big one. Okay, labor is always the big one. And then occasionally they will throw on some type of unit of physical capital. Whenever they're talking about farming, they almost always use tractors. That's like their big thing is tractors. Whatever factor of production you're going to use, you treat it the exact same way. The only difference is if you're talking about labor, when we say the price of labor, we refer to that as the wage. That's how much labor is worth, is the wage that companies pay. When we talk about other factors of production, instead of using the term wage, they use the term rent. Whatever it is that you pay in rent for that particular object or land or whatever it might be. So that's really about the only difference between the factors of production. But for the most part, in these YouTube videos, I'm going to stick with labor just because it's easier. It's something we can all relate to. So that's kind of what we're going to look at today. Now, the first video we're going to do is talking about in a competitive market, what happens in a competitive market for labor. The second one will be what happens in a non-competitive market for labor, which is called a monopsony. And we'll get to that one in video 2. But this one today, we're going to be looking at competitive labor markets. So just like we did in perfect competition with profits, we're going to have a side-by-side graph, or two side-by-side graphs here. These are actually, I think, quite a bit easier as far as the side-by-side. The first one is going to be sort of the market for a product, okay? The market for a particular product. So let's say ice cream as an example, okay? So we've got a market here for ice cream. And then next to that, we're going to have the market for, I don't know if there's a specific word for this, but we'll call it ice cream workers, okay? Ice cream workers. I don't know if there's another term for ice cream workers, but we'll just call it ice cream workers, okay? So over here, we're going to have a supply curve and a demand curve for ice cream. There's the quantity of ice cream. There's the price of ice cream. Over here, we're going to have the supply of labor. That L is for labor. The demand for labor. The quantity of labor, which is the quantity of workers that are hired in an industry. Quantity of ice cream workers hired. And then over here for price, we're going to actually call that W for wage. That's the wage that we pay these ice cream workers. Okay, so this concept that we're going to see here, these two graphs side by side, it gets to the concept of what we call derived demand. Derived demand essentially says that the demand for one thing comes from something else, okay? It's basically how we figure something out, is we derive it. So as an example, from some of the questions that I've been getting on Google Classroom or some of the comments, I have derived that there's a few of you that have not been watching the YouTube videos, okay? The comments or the different things that you've said have made me believe that, maybe they didn't watch that. I'm deriving that, okay? Same concept here. We're going to derive the wage for ice cream workers from this graph over here, from the market for ice cream. Sometimes we say we derive it from the demand for ice cream. That's partially true. We actually derive it from the price for ice cream. So what this means, let's say as an example that we get a a massive heat wave that goes through in May. Hopefully not. It's actually beautiful today. But let's say we get a massive heat wave that goes through Gainesville in May. If that's the case, what do we think is going to happen over here in the market for ice cream? Well, more than likely, the demand for ice cream would increase. We'd have an increase in demand for ice cream. If there's an increase in a rightward shift here, we know we're going to be selling more ice cream. And also, the price of ice cream has gone up. Now, this is the key part, the price. Imagine you own an ice cream parlor. If the price of ice cream that people are willing to pay has gone up, what do you want to do? You want to make more of it, okay? Our number one goal, we're trying to make money as a business owner. So if the price of ice cream has gone up, we want to make more of it. How do we make more of it? We need to get more workers, okay? So when this price increased, what that did over here, we're deriving our demand for these ice cream workers from this graph and from specifically the price. So when the price is higher, man, we need to get more workers. We need to increase the amount of workers that we've got, so the demand for labor is going to go up. That means we're hiring more workers. That also means that we are paying them in order to get them to work. We're going to pay them a higher wage, okay? So you may say, well, yeah, that's kind of common sense, and it is, but the key thing where people get confused is they always say, oh, well, the demand here always equals the demand here. Not necessarily. It's more about the price, and I'll give you a quick example. If you've ever seen the show Deadliest Catch, okay, where they are fishing for these big Alaskan king crabs, the reason they're doing that, okay, the reason they I mean, to me that just looks miserable, be on this boat that's rocking every which way and being cold and doing all this manual labor and not being able to see, anybody for 5 months or 4 months at a time, whatever it is. It looks miserable. Why do people do it? Well, because the wage is really high, okay? You know why the wage is so high? You may say, oh, well, it's got to be that the demand for king crab is super high. Well, the demand for crab is fairly high, but more so it's because the supply is fairly low, that the supply is low, and that's what jogs the price up. Why is the supply low? Because who wants to do that? It's a really tough gig to go out there and catch all of those crabs. So the supply being low drives the price up, and because of that price being high, then the demand for labor is going to be high as well, and we're going to have to pay a higher wage to get people to do that, to be able to get people to comply with that type of thing. So the demand for labor always derived from the market for the product. Now, the supply for labor, not necessarily the same thing, okay? That is not always derived from from the market graph. There's a lot of other factors, things like birth rate, okay? We see with populations, you've probably heard about or talked about in history, the baby boomers, how they're all getting ready to retire, or they all are retiring at this point. What does that do? Well, that actually, because there's so many of them, that actually drops the supply of labor because they're all getting out of the labor force, okay? There's not a particular demand thing over here that affected it, or price over here that affected that situation. It was just they're all old farts, and now they're retiring, and so the supply of labor is decreasing. If we were to relax immigration policy and allow more immigrants into the United States, that would increase the supply of labor. Again, that's not due to something that's happening over here with a market graph. That would just be policy driven. So the supply of labor does not necessarily get derived from a graph over here, but the demand for labor will get derived from that. Okay, the next thing that we need to look at before we leave off with this, we've got to take a look at what are other determinants with the wage and what are other determinants with this demand for labor. So I'm going to erase these graphs here, so if you need to pause and copy them, knock yourself out, okay? But we're going to talk a little bit about how a firm will decide exactly how many workers to hire and what that demand for labor is sort of based on. So if we've got an individual firm Let's say this is, I don't know, Ike's ice cream, okay? I like alliteration today. So we got Ike's ice cream here, okay? We're going to have our supply of labor right here, okay? We're going to have a demand for labor that's coming through here, right? And this demand for labor is going to be equal to what we call our marginal revenue product of labor. You go, marginal revenue product of labor, what does that even mean? That marginal revenue product of labor essentially means how much money is each worker going to bring in for you, okay? So the reason that this is going to be downward sloping, and I'm going to erase this supply of labor here just for the moment to try to make this look a little bit simpler. The marginal revenue product labor is saying how much they each bring in. Well, that's essentially based on a quick calculation. What is the price of the product and what is the marginal product of a particular worker? Now, if you remember, marginal product is just how much each worker makes in terms of a particular product. So if we have in ice cream, let's say that Ben is making 10 pints of ice cream an hour, okay? So we say Ben's marginal product here is, let's say, 10, and we're selling these for, let's say, $4 a piece, okay? That the price of each of these is 4, and I say pint, but like the cups, the large cups, okay? $4 a piece. Ben makes 10 of them, okay? 4 times 10, Ben's marginal product of labor is $40. That's how much he brings in for the ice cream parlor. Then let's say after that we hire Sean. Sean, let's say that his marginal product is 8. Okay, he's able to make 8 in an hour. And so again, we do 4 times 8. All right, and so that tells us, okay, 32. $32 is how much Sean brings in for us in the course of an hour. Now, the reason that this is going down, we know that over the course of time, once the benefits of specialization have dissolved, we know that we get diminishing marginal returns. That because we have too many cooks in the kitchen, too many people in a confined space, that eventually each worker makes a little bit less. They screw around, there's not enough space, so they're bumping into each other, they get bored, they get tired, whatever it may be. We know each additional worker makes a few less, in this case, cups of ice cream. They make a little bit less. So what we're doing with this graph, we're taking out the part where it was increasing, where people were making more with each worker because of specialization, and we're just kind of looking at the downside. We're just looking at where diminishing marginal returns have already set in. So each worker is making a little bit less, and so their marginal revenue product of labor is going down for each worker. So let's assume that we're paying all of these workers exactly the same wage because it's a competitive market. Okay, so I'm going to put a wage over here. Okay, that we're paying the workers exactly the same wage. Let's say that we're paying them, I don't know, $12 an hour. Okay, if we're paying them $12 an hour, well, Ben, way up here. Okay, we love Ben because he's making $40 an hour for us. We're only paying him 12. We're making $28 profit off of Ben. And then I think we said Sean was 32, and we're paying him 12, so we're making 20 off of Sean. We're going to keep hiring workers. In that case, we're just going to keep hiring until we get right about here, where the wage is equal to that demand for labor. Reason being, at that particular point here, there's your quantity of workers hired. At that point, this triangle is representing all of the profit that we have made off of those workers, okay? So maybe we had somebody down here, maybe we hired Avery and she made $16 for us in terms of the marginal revenue product of labor. So she made 4 in an hour, okay? She made 4 cups an hour, we sold them $4 a piece, $16, we're paying her 12. Hey, we still made $4 profit. But once we get down to somebody that's only making 3 cups an hour, we're done, okay? We don't want to hire beyond that, because if we're hiring somebody that only makes 2 in an hour, they're bringing in 8 and we're paying them 12, we're losing money on that person. So we only want to hire up until this point, and at that point we've captured all of the profit that we can get from our workers, okay? So that's basically how marginal revenue product to labor works. That's basically how we figure out how many people we should hire in a firm. I know I went through that fairly quickly. If you have questions, I am begging you, drop them in the comments, throw them on Classroom, email me. I would love to answer questions about this, or come to office hours. We'll have office hours a couple days this week, which I'll put on. I know Friday for sure. I can't remember if the other one's Wednesday or Thursday, but I'll have that on Classroom as well. So please drop in if you have questions on this. I want to make sure that you all understand it. Thanks a lot for listening, and we'll see you all later.